Hello everyone, my name is Mohammad Hamzarif. I'm here to present our project, which is deep learning for automated medical diagnosis with my team members, which is Vishnu, who is project manager, Anukti, who is data scientist, Monali, who is developer, and Bilal Hai, who is machine learning engineer. Next slide, please. The introduction of deep learning in medical automatic diagnosis. This project focused basically on deep learning medical techniques for automated medical diagnosis. In this project, we are going to develop a web-based or a mobile-based application using a Python to detect the diseases. Some of the key points of our project, which involve data collection. In this part, we will collect the data like X-rays, MRIs, and CT scans, and then uh, we will use their data and we will diagnose the disease by using these data collections, and we will process that data. Model selection and implementation. In this part, we will select the model. There are two or three models like CNNs, RNNs. We will decide from these which model we are going to use. After that, there is training and evaluation, in which we will split the data into training, validation, and test. Use approach loss functions. And after that, there is deployment and integration. In this part, we are going to deploy the techniques in which we gonna diagnose the disease. We will convert the model into effective formats, and we are going to use Flask-based web application for that person. And at the last part is ethical consideration and challenges. In this part, we are going to make sure that the data of the medical professions and the patient will remain safe and secure. And for that part, we will make sure that our project is up to date with HIPAA and GDPR regulations. And the next slide, please. These are the main objectives of the our project. Deep learning is basically a model in which we are going to use techniques for the medical diagnosis by using a Python app. We will going to analyze X-rays, images, and CT scans, and we will going to develop a predictive model for disease detection and classification. We will enhance diagnostic effectiveness and precision in using that technique. It will be more accurate for diagnosing the disease. In this By using these techniques, it will be a minimum workload for medical profession, and there is no chance for the human error. We are going to provide a user friendly web app for that person, for that technique. And at the last, we will make sure that which is the most important thing is the privacy. We will make sure that the data of our customers and professional remain secure. Next, I'm going to invite Bilal Hai to continue further with the presentation.
Hi, my name is Bilal, and today I am here to present my two concept, which is deliverable and assumptions. I'm start with deliverables, which has six concept. Which is web-based application. We use technology here for front end is JS, React, HTML, CSS, and JavaScript. For backend, we are using Python for API request and data processing. Further is deep learning models, CNN and VIT architecture for disease detection. And next one is image processing and processing pipelines. The key features we are discuss here is normalization, augmentation, and enhancement to improve image quality and model performance. Here we use decom file, which is very efficient to handle medical images standard. And another technology which are we are using here is normally deduction, which is used for poor quality of the image. Next is API development. First one is Flex and Fast API, which is using to image upload model interface and API interface. Next, we are using Slurry and Rabbit MQ. The purpose of this technologies is efficiently handle large volume of image. Further is deployment and cloud integration. For deployment, we use Docker application. The purpose of this application simplify deployment, and the cloud integration is the cloud integration is simple. We are using AWS, GCP, and Azure here. The final is a report we generate PDF report for the whole process. Next slide, please. Next slide. The next slide is for assumption. There is four concept: data availability and access. OpenSS database utilize public available database for initial development and model training. And we are collaborate with different hospital for collecting feedback from real time data. That thing is really important to improve our application. Here we're using PY Torch and TensorFlow for developing the tool. Here is from my side. Next, I invite Vishnu to continue further.
Hi guys, welcome everyone to the presentation. And in this session, mainly I will focus specifically on key constraints faced in this project and methods of communication by using this collaboration. And let's begin by understanding the challenges. Here are mainly the key constraints that are addressed for successful implementation. In this project, mainly it's related to the data and computation and interpretability and real-time development and some regulations. By overcoming these challenges, it ensures that deep learning model is very reliable and effective. And here are mainly five constraints. The first challenge is obtain that high quality medical images that data sets while adhering the ethical guidelines and privacy laws. Computational resources also pose a challenges, and deep training models requires high-end GPUs. The mainly in interpretability is another key issue in healthcare professionals need to trust AI predictions. Real-time processing must be optimized mainly to handle the large data sets effectively. Finally, the regulator compliance is a major factor of our model and must meet the medical industry some standards. And while coming to this, next slide. Here are the methods of communications. We adopted some multiple communication methods to ensure our efficiency and coordination. There are some weekly team meetings that will help our progress in tracking and problem solving. The project management tools such as Jira and Keep Task Organized. The version of the control mainly it performs like GitHub, and it will allow the seamless collaboration on the code. Documentation tool, it will help in maintaining the detailed project records. Finally, the communication ensures the transparency and some feedback integration. And while coming to the conclusion of my part, to summarize, we have discussed some major constraints that impact our project. We have some plan to overcome this. And we also explored the communication strategies to ensure the smooth collaboration of this project. Moving forward, we will focus on some optimizing models and testing the real-time development and preparing some documentation for my final presentation. That's it. And next, my teammate will be joining.
Thanks, Bilal. So I'm gonna talk about the work breakdown structure. So the project that we developed is a medical diagnosis system using deep learning techniques. The work breakdown structure includes project planning and research, which has defining the scope, literature review and gathering data sets, data collection and pre-processing, which includes acquiring medical imaging data sets, cleaning them and splitting the data, model training and model selection and development, model training and validation, model evaluation and performance analysis, deployment and integration, testing and validation, documentation and reporting, cloud deployment and maintenance. So under all of these main categories, we are doing all of these steps, which I have mentioned in this breakdown structure. So far, we have come up to some level, but we have more to go on. If I'm moving into the next slide, it's the Gantt chart. This outlines the project phases, which is research, data collection, model development, training, evaluation, deployment, and testing. The initial weeks focus on literature review, dataset pre-processing, and model selection. The mid phase, which we are right now, covers training, validation, and hyperparameter tuning. The final weeks parallel for efficiency, ensuring timely completion. The structured timeline optimizes workflow, allowing a medical diagnosis system with cloud-based deployment and real-world applicability. Next, I'm moving into the process of developing the system. First, we've gone identify the problem and we collected the data. The data which is like some medical conditions, the data sets like X-rays and MRIs from different sources. And then we process the data by cleaning, normalizing, and augmenting data. And we handled the missing values. Next, we did the exploratory data analysis. That is visualizing data, checking the class distribution, and identifying different patterns. After that, our process is to start dataset splitting, which includes 80% training, 10% validation, and 10% testing. The next step is for the model selection and architecture design. Here we have to choose the deep learning model, which is either CNN, RNN, or something else. And we have to define the layers, loss function, and optimizer. The next process is the model training, where we train on the data set and we monitor the accuracy, loss, and performance. Next, we do the evaluation and fine tuning. We test the model on evaluation and the data, and we then run hyperparameter tuning for avoiding overfitting. And then the last one is the deployment and monitoring. At last, we deploy via API, Flask, or something, and then we track the real-world performance and update the model. Next, I'm going to pass into Monali. She will be continuing the rest.
Thank you, Anna. In the slide, you can see the backend part of the code snapshots. This is a class-based medical diagnosis tool, so which is made to predict diseases like heart disease, cancer, and kidney disease. Predict. Vishnu, can you stop the recording?